Today we're going to look at solving square root equations again. Today we're going to start with what we know and then increase the level of difficulty. So go ahead and pause the video and try letter A. What is your first step? Your first step should be to isolate the square root. Okay, your first step should be isolate the square root. So what that means is you're going to add the square root of x plus 2 to both sides of the equation. What is step 2? Step 2 then is square both sides of the equation. Again, step 2 is square both sides of the equation. So when I square both sides, I get 3x plus 4 equals x plus 2. Based on what we learned yesterday, what is step 3? Step 3 is solve the resulting equation. So I will subtract x from both sides, subtract 4 from both sides, and I get x is -1. What is step 4? Step 4 is check your solution. Step 4 is check your solution. So what I do is I go to the original equation, and I'm going to take 3 times -1 plus 4 minus the square root of -1 plus 2, and I want to know, does that equal 0? So, does that check? I get the square root of 1 is 1, minus the square root of 1 is 1. Does that work? Yes. So, in my answer blank, I'm going to put x equals -1. All right, step 1, isolate the square root. So what would you need to do to both sides of the equation in part B that would isolate the square root? Well, if you said subtract 1 from both sides, you are correct. What is step 2? Step 2 is square both sides of the equation. A square root and a square cancel. What's step 3? Solve the resulting equation. So I subtract 5, divide by 2. What's step 4? Check your solution. So I go to the original equation, plug in what I got, and I want to know when I plug in x is 2, does the left side equal the right side? I get the square root of 9 plus 1. Does that check? Yes, it does. So in my answer blank, I put x equals 2. So A and B are a review of what we did yesterday. Letter C, what is step 1? Step 1 is isolate the square root. So I can add x to both sides of this equation. All right, what is step 2? Step 2 is once you have the square root alone, you're going to square both sides. So I get 2x plus 7 equals. Now remember, if I have a sum that's being squared, there is no distributive property for exponents with a sum. Okay, there is no distributive property for exponents. But what I can do is I can multiply that out and get x squared My outer is 2x, the inner is 2x, so that's 4x plus 4. Let's get everything on one side of the equation. What method would you use out of our different strategies? Quadratic formula, completing the square, square root method, and factoring. What would be the most efficient, fastest method? If you said factoring, you are correct. You can do quadratic formula, you can do completing the square, but that's not the fastest. So I'm getting x is -3 and x is 1. All right, so we isolated the square root, we squared both sides, and we solved the resulting equation. What is step 4? Step 4 is check your solution. So you go to the original equation and you want to plug in, we're going to plug the first number in. So I get square root 1 plus 3 equals 2. Did that work? No. So this one is going to be what we refer to as an extraneous solution. Now let's check x is 1. So I have 2 times 1 plus 7 minus 1. Will that equal 2? Square root of 9 minus 1. Does that one work? Yes. So x equals 1. Something I want to mention again that I had mentioned yesterday in our day 1 is it's possible that both answers work. It's possible only one works, and it's possible that neither of them works. I don't want to mislead you to think that negative values don't work. Sometimes the negative value works and the positive one doesn't. It just depends, and you must check all solutions. All right, letter D. This one is really a challenge problem, but I know quite a few of you can do this. So I'm going to go ahead and show it to you, and there will be, I believe, one problem or two on the homework at this level. So again, there is no distributive property. I cannot say that I'm going to square the 3, square the first square root, and square the second square root. There is no distributive property like that. What I can do is I can isolate one of the square roots. Okay, so what I can do is I can add the square root of x plus 5 to both sides of this equation. All right, now when I square both sides, here's something really, really cool. Okay, I want you to look back to letter C. This is like this row right here. I'm squaring, but it's flip-flopped. This is the square root, and that's going to undo on the right side. So this side is 4 minus 3x. But over here, do you remember how I had an x plus 2? And I can't say that's x squared plus 2 squared. Similarly, I can't say that's 3 squared plus the square root of x plus 5 squared. There is no such math property that says that. And we've gone over that and over that and over that. And we're going over it again. So what I can do is I can take 3 plus the square root of x plus 5 times 3 plus the square root of x plus 5. So then I'm going to FOIL. 3 times 3 is 9. My outer is 3 square root x plus 5. The inner is 3 square root x plus 5. Then what happens when I do the last? When I take square root x plus 5 times square root x plus 5. It's just like this side over here. When you take a square root times itself, a square root and a square are inverse functions, and they undo each other. So that's x plus 5. Okay, so on the left side now, let's collect some like terms. So here's the good news. I went from having 2 square roots Now I've got it down to 1 square root. And I want you to notice back to letter A. Letter A is different because I had it equal to 0. So I could just add the square root of x plus 2 to both sides and have 1 square root equals 1 square root. The difference is this does not equal 0. So all I can do is isolate the square root. So I'm going to subtract the 14 and I'm going to subtract the x and get 6 square root x plus 5 equals negative 10 minus 4x. Now, I want you to notice that all the coefficients are even. So I am going to divide everything by 2 and make my life just a little bit easier. Okay, if you do see a common factor, a common constant factor, you can divide that out. All right, so now I'm going to square both sides. Well, that means I'm taking 3 square root x plus 5 times 3 square root x plus 5 equals negative 5 minus 2x times negative 5 minus 2x. I'd encourage you to pause the video and try this one. Hopefully you paused it. 3 times 3 is 9, and a square root x plus 5 times a square root x plus 5 is x plus 5. Now I'm going to FOIL on the right side. Negative 5 times negative 5 is 25. The outer will be a positive 10x. The inner is a positive 10x. And the last is a positive 2x squared. So I'll use the distributive property on the left side to give me 9x plus 45 equals x squared plus 20x. Oops, sorry, my bad. That is not an x squared. Just caught myself. Negative 2x times negative 2x is 4x squared. There we go. 4x squared plus 20x plus 25. I'll subtract 9x and subtract 45 from both sides of my equation and get 4x squared minus 11x minus 20. I strongly recommend that you try to factor. And this one does factor. I do know that I can't put the 4 in with the 4x because there wasn't a GCF. So I'm going to try a 4 and a 5, and I'm going to get 16, negative 16 plus 5, and that's going to check. So I get x is negative 5/4, and x is, whoops, sorry about that. I have those backwards. Good thing I'm checking my work when I factor. There we go. So I'm getting 4x minus 5 and x minus, or plus 4. There we go. That does the job. Now check those, okay? This was a lot of work, okay? This was a lot of work. So if I go back to the original equation, I'd have 3 equals the square root of 4 minus 3 times negative 4 minus the square root of negative 4 plus 5. So I get 3 equals the square root of 4 plus 12 minus the square root of 1. That's the square root of 16. So the x equals negative 4 actually works. So just like I mentioned on the last example in letter C, just because it's a negative doesn't mean that's not going to work. You just have to check. So then let's check this next one. 4 minus 3 times 5/4 minus the square root of 5/4 plus 5. All right, this one's going to be harder to check because of the fractions. So I'm going to build common denominators here. So 5 is 20 over 4. This would be 16 fourths minus 15 fourths, 25 fourths, square root of 1/4 minus 5 halves, 1/2 minus 5 halves, and this one's a no. So that was an extraneous solution. All right, again, letter D, that's a very, very advanced technique where you have to square twice. All right, that wraps it up.